We'll talk about the charging station. This presentation comprises two sections. It's about the structure and equipment of charging station and some things regarding the installation charging station, grounding and their corresponding protections. First of all, we have to underline that this issue is dedicated to electric vehicles, which are nowadays very trendy, and it seems that in a few years they'll conquest completely the transportation, both for public transportation and individual transportation. One of the most benefits of this kind of transportation is that pollution becomes completely avoided. It means that the emission of CO2 will decrease constantly, and the pressure that the government and all the governments all over the world and the institutions are making of using more and more electric transportations. One of the main issues is that all these kind of vehicles are to be charged from different devices. Nowadays, the electrical motors, regardless their type, we are talking about the AC and DC electric motors, are to be driven by some other equipment, such converters, such a conveyor, and other electronic equipment. But the main energy sources is taken from these charging stations. Their types and their particularities are very complex. It means that there are many types of such equipment, starting from in terms of their rated power, in terms of their design, in terms of their features. Here are only some of these charging stations. There are some wall-mounted, there are some individual charging station or other types. Of course, the variety of electric vehicles is also very large. We are talking about now only about the pure electric vehicles that are driven by pure electric motors. Only in this way we can ensure we can fulfill the requirement of having zero emissions. One can say that the main component of such electric vehicles are comprises by electric motors, regardless what type of it, and electric battery, in which practically immagazinate the whole energy. There are also hybrid electric vehicles, but these are not not discussed in this presentation because they also, as you probably know, use classical energy type in terms of gas or in terms of diesel. In the last time, all the nations are trying to replace the actual electric diesel or gas electric motor with electric motors. That means that also the hybrid types are also considered. But these hybrid types becomes very difficult to maintain their fiability and their long time operations. That's why electric vehicle is the best way that suits our requirement in terms of CO2 emission, in terms of pure electric consumption and using zero gas or diesel. The main components are the electric motors, the battery, onboard charger, charging inlet, if it is an EC charger, and charging inlet, it is a DC fast charging. About this issue we'll talk later, and we'll present the advantages and disadvantages of each type of charging inlet. The big problem of electric charger is that nowadays there are so many types. They are not still standardized. Every car producer produce its own type of electric vehicle charging. In terms of electric parameters, that can be very difficult and rather confusing, because once you have a certain electric car, let's say produced by one of the well-known electrical car producer, European or from Asia or from other part of the world, they again develop their own charging stations. That means the parameters of the charging station are very different. They could be AC or DC. So we have to be very careful. We have to read properly the parameter, the electrical parameter of this charging station, because only in that term we can make different comparisons. It's very difficult to compare something that has different parameters, and that's why we have to underline that when you want to compare such devices, we should be very careful their electrical data. And by electrical data, I mean, first of all, the rated data, the rated power, the rated voltage, the rated current, and also other power quality issues, which are very important here too. Here you can see that we have in different part of the world different types of chargers, different type of plugging and sockets. Some of them are wall mounted, some of them are even ground mounted, some of them are practically in a wall. These differences make it practically impossible to determine which of this is the best or the most suitable solution for a certain car. That is practically imposed by the car manufacturer. The car manufacturer, the electric car manufacturer, developed one of these chargers type and practically spread out all over the world. Regarding the DC and the AC charging, one have to know that practically most of the electric car are, in terms of their driving solution, are DC cars. So practically even the charger is an AC type, the car will use DC. That requires, of course, a rectifier. And this rectifier in some of the chargers is placed within the chargers. Some other old model cars, for instance, they have this rectifier inside the car. And after the charging process, the car is practically plugged to the charger, the current will be transformed in DC charging. Because again, the motor that is to be driven in different specific modes, it's a DC motor. And there are that, of course, here we have, for instance, all mounted, and another feature that is very required nowadays and very common is the communication system. Not only that the charger has to provide the specific electric parameter of the required power, but it also must have a communication system in that manner that not only the driver but the charger owner to know everything about the electric parameter energy consumed from this charger. I mean, when it is consumed, which is the level of the charging process of the car, which is the power energy charger types, and which is the cost of this power energy consumed by a very specific socket. And what is the most important thing? It is to know the charging level of such cars. Anyway, here are also floor standing electric vehicle charging station and the wall mounted charging stations, yes, from different mode of car. And of course there are also very powerful charging stations, and this mode, so-called mode 4. The charging station are very powerful and usually designed for large car like buses or trucks or any other car, powerful car for transportations and other purposes. The main issue regarding these electric vehicle chargers is that nowadays we practically require a lot of energy taken from the network, for the actual network. And the problem is that in some countries, like Romania, for instance, but of course there are other countries, is not very enough investigated if the network can endure such a power absorption in a very short time. What I mean is that during the time, the electric car will increase in number, and practically all of them will demand energy from the charging station. Some of the electric energy supplier provide such charging station. Even we have different programs that practically demand from the renewable energy producer to install such devices in different places like supermarkets, like I don't know, gas station and so on. But the problem is that the number of the electric cars is constantly increasing, and anyone can raise legitimately the following question: will the actual network, the actual grid, be enough for taking out this kind of energy, because nowadays we don't have enough studies, enough electric energy studies regarding the capability of our network. There's another question, because a modern electric car, let's say that require for fast charging 22 kilowatt at instant, and let's imagine that in a neighborhood we have 100 such cars, yes, and the network in that area will have the same size, designed for only domestic consumption. That means TV, some sort of electric domestic devices, and the power demand is very huge. And I'm very sure that the transformer nearby that supply this network cannot endure such demand of power. And that means that in the next future we have to develop to straighten up our network and our grid in order to supply and to endure such a high demand of power in such a short time, because everybody who has such a car like Tesla or like other, I just said Tesla because it's very common and everybody know what it is. And by the way, they also develop a new chargers, an universal charger system for such vehicles. And let's say, imagine this scenario that in a small neighborhood, let's say that the population in that area, all they want to charge their car during the night. What happened in that period? Because the transformer again that supplies this network will not be able to provide such an amount of energy in such a short time. And that's why I think a power energy study flow is to be provided before installing such devices in a large area. That will happen other countries like United States, when I have information that practically in different area they cannot supply such amount of power. For instance, European countries, the network is good, and in some area it was straightened up in order to endure such peak power demand. It's called peak power demand because they, again, all these electric car owners demand the power in the same hour, almost the same hour, and the same level of power, up to starting up with 22 kilowatts, which is a great power. And that's why, again, these studies are to be provided in different network, and once we want to develop a very good network, we have to consider all these issues. And beside that, we have to compare this charging station in terms of their fiability, in terms of power quality disturbances they can make cause during the network. Nobody considered that practically this rectification process from AC to DC pollute the network and generate numerous power quality issues that are to be considered and are to be treated in a specific manner depending on the severity of such chargers. But again, we have to analyze the future development that practically it is in very short future. In a few years, we have to consider that. Otherwise, we are vulnerable to power failure of the network. It is true that continuously or in the same time with the development of electric car, other energy renewable sources are developed, such a photovoltaic plant, such a wind plant that can practically supply the energy need and the electricity need. But not the energy is the issue. The issue is determined by the network itself. The network itself, the cable, the apparatus, the electric panels cannot endure such amount of fast power demand. That's the most important thing for our country, because we have, again, to consider all these issues. Thank you very much.